Lesson 5.2, Graphs of Sine and Cosine Part 2. Students will use functions of the form f of x equals a sine bx and f of x equals a cosine bx in order to correctly graph sine and cosine graphs with different periods. Now last lesson we just focused on the a that was out in front of the sine and cosine function, but now we're going to talk about the b that comes before the x. And in order to do that, we're going to graph two graphs. First we're going to graph sine x, we're going to graph that in red, and then we're going to graph the simplest version of sine bx, which is sine of 2x, on the same graph. So here's the graph, and here's the very familiar graph of sine, is the red line. And then we're going to make a table to graph sine 2x. Now, every time we graphed sine, we use the same x values. We use 0, pi over 2, pi, 3 pi over 2, and 2 pi. So that's what I'm going to do here. Sine of 2x, well, 2 times 0 is 0, and the sine of 0 is 0. So the first dot, it's still on 0, 0. Then over on the table, if I plug in pi over 2, well, 2 times pi over 2 is just pi, and the sine of pi is 0. So the x and y coordinates are pi over 2, 0, which is right there. Then I have put in pi. Pi times 2 is 2 pi. Sine of 2 pi is 0, so the coordinates are 0, pi, 0. Okay, then we put in 3 pi over 2 times 2 is going to be 6 pi over 2, which is 3 pi. Sine of 3 pi is 0. So again, we have 3 pi over 2, 0, which is there on the graph. I have 4 dots now. Then I have 2 pi, which when I multiply it by 2 is 4 pi. And when I take the sine of that is, again, 0. So I have 2 pi, 0. Now you would think by looking at that the answer would be a straight line, but it's not, because it's sine, and that means it is periodic, and that a straight line is not a periodic function. So we have to figure out where sine is going to be at the biggest and the smallest. And if you look at the red graph, halfway between 0 and pi, which is at pi over 2, which is halfway between the two again, that's where you reach your highest point. So between the first two zeros, halfway you get the highest point. But same thing is going to happen on the blue graph. Halfway between 0 and pi over 4 is 0 and pi over 2 is pi over 4. So pi over 4 times 2 is pi over 2, and then take the sine of that, it's 1. So we have pi over 4, 1. And then halfway between pi over 2 and pi is 3 pi over 4, right? 3/4 pi is halfway between 1/2 pi and 1 pi. Multiply it by 2, I get 3 pi over 2. Take the sine of that, I get -1. So there's my -1 on the graph. And hopefully you can see the pattern. Halfway between each one is either going to be a maximum or a minimum. And then I draw that graph. Okay, and I draw it both ways. Now you'll notice, let's look at the periods. What's the period of sine x? Well, if we start at 0 and we trace the red line, you'll notice as you trace the red line, you won't get back to the same place doing the same thing, which is starting at 0 and going up until you get to 2 pi. So the period's 2 pi. And that's the period for sine x, and that's the period for cosine x, as long as there's no number before the x. And so we look at the blue. We start at 0 going up, and we follow the blue line. We'll find that we repeat ourselves after pi. So what do we do to get from 2 pi to pi? Well, that's a pretty simple answer. We divide by 2. And the reason we divide by 2 here is because the number up top, sine 2x, the 2 there is the reason you divide by 2. So here's the formula for you to put it all together. That's the form of function that we're dealing with in this lesson, a cosine bx. We know that the a, and we know this from last lesson, the a is the amplitude of the function. And we know that b helps us get period, but it isn't the period of the function. In order to get the period of the function from b, we have to do 2 pi divided by b, because 2 pi is the period of the original function, and you divide by b to get the period of the new function. Here's an example to graph. I want to graph y equals 2 sine 4x. Well, I know the amplitude is 2, and I know to find the period I have to do 2 pi divided by b, which in this case is 2 pi divided by 4. And 2 pi divided by 4 is pi over 2. So the period for this function is pi over 2. So just to graph that out, I'll put a graph and I'll put a table. And you notice that this graph does not go all the way to positive 2 pi and negative 2 pi. It stops at positive pi and negative pi. And I know at 0, this function is going to be at 0. And at pi over 2, this function is also going to be at 0, because when you get to the end of a period, you have to be back at the same point you started. So if you start at 0, by the time you finish one period, which is at pi over 2, you're at 0. And I know in between, if it's sine, it goes from 0 to 2 because the amplitude is 2, back to 0, down to negative 2. But I need to find the x coordinates for those 3 y coordinates that I know I'm going to see. Okay, well, I know it goes back to 0 halfway between 0 and pi over 2, which is pi over 4. So there I put pi over 4 for the x coordinate. I know it's going to get to the positive 2 halfway between the 2 zeros, which is what we did last time. So halfway between 0 and pi over 4, which is pi over 8. And I know it's going to get to negative 2 halfway between pi over 4 and pi over 2, which is 3 pi over 8. So the graph looks like this. You notice that it goes from 0, 0, 0 to pi over 8, 2, because each tick mark in this case is pi over 4. It comes back down to pi over 4, 0, then to 3 pi over 8, negative 2, and then pi over 2 back to 0. And that's, of course, going to repeat. It's going to repeat going the other way as well. So that's the graph of the function 2 sine 4x. Next example. Now we're going to graph the function y equals cosine 2/3 x. This is a function that most people freak out about because it's got a fraction in it instead of a whole number, but we still use exactly the same method. So the amplitude of this function is 1, and the period is, remember, 2 pi over b, and in this case b is 2/3. So the period is 2 pi over 2/3. Okay, in order to do that, I flip, when I divide by fractions, I flip and multiply. So that becomes 2 pi over 1 times 3 over 2. I flip and multiply. The 2's are going to cancel out, and I'm going to be left with 3 pi over 1, or 3 pi. Now, I need to find, remember, last time I did the function, I divided that period into 4 equal parts. Okay, and I'm going to do the same thing here. I'm just going to do it a little bit differently. Okay, there's my table. I know it starts at 0, 0, 1, because this time it's cosine, and cosine starts high. And I know it goes 3 pi 1, because it's cosine, and cosine ends high. And I know in between, I'm going to do 0, I'm going to go down to negative 1, and I'm going to come back to 0, because that's the pattern for cosine, I'm sorry. And this is how I'm going to find those other 3 points. I take that period, and I multiply it by 1/4, 1/2, and 3/4, because that gives me the 1/4 mark, the 1/2 mark, and the 3/4 mark, and that's going to divide our period from 0 to 3 pi into 4 equal parts. So 3 pi times 1/4 is 3 pi over 4. Okay, 3 pi times 1/2 is 3 pi over 2. And 3 pi times 3/4 is 9 pi over 4. Now, if you wanted to do this the easy way, you would use those as your x-axis tick marks. 0, 3 pi over 4, 3 pi over 2, 9 pi over 4, and 3 pi. And just make the function relatively normal with those as your tick marks. But I'm going to show you how to do it a little bit harder way. And that's this. You'll notice that I go from 0 to 4 pi on the graph. And I just brought the same table that I had on the last page. So I take this and I mark 0, 1. Okay, is where 0, 1 is. 3 pi over 4, that's going to be 3/4 of the way to 1, because in this graph, each tick mark, each line in the grid is 1 pi on the x-axis. So it's going to be 0.75 pi, 1.5 pi, and 2.25 pi. And you see that right there. See, I have 0, 1, I have 0.75 pi, 0, I have 1.5, negative 1, and I have 2.25 pi at 0, and I have 3 pi 1. And then I just continue that same graph to the edges of the graph. And that's how you graph functions of the form cosine bx when b is a fraction. Now, the last thing we have to be able to do is to find the equation of a graph based on the picture. So if I look at that picture, I'll immediately see that it starts high. So that means that we're dealing with cosine instead of sine. And I notice that the amplitude of that function looks like it's 1.5, but I don't want to put it like that. I want to put it as an improper fraction. 1.5 is 3 over 2. Okay, so that means in the function a cosine bx, a is going to be 3 over 2. Now I need to find the period. And I know the period in this case is 4 pi, because we start at 1, and when we get back up to 1, that's at 4 pi. So 4 pi, and when I know 4 pi, which is the period, equals 2 pi over b. So that's like 4 pi over 1, and I cross multiply because there's an equal sign in between fractions, which is 4 pi times b equals 2 pi. Okay, then I have to divide both sides by 4 pi to get the b by itself, so b equals 2 pi over 4 pi. The pi's cancel out, and all that's left for b is 1/2. So the answer to this equation, I have this line, the equation is f of x equals 3 over 2 times cosine of 1/2 x. And I'm going to go ahead and put your homework up so those who missed the lesson can get it here, and if not, you can get it here.